Okay, so hello everyone and welcome to the OneClass channel. My name is Donna and I'm a recent master's graduate from the Materials Science program from the University of Ontario Institute of Technology, also known as Ontario Tech University. So today we're going to go over some commonly asked questions in chemistry at the high school, college, and university level. So if you needed any help with homework or with tutoring, then check out the links in the description below. Now let's just get started on our set of questions for today's session. Okay, so question 1 is to draw the Lewis structure of selenium dioxide. Okay, so when we want to find the Lewis structure, first we need to calculate the total number of valence electrons in this molecule. Okay, so in the case of selenium, selenium has 6 valence electrons, and oxygen also contains 6. And there are 2 oxygen atoms, so we just multiply this by 2, giving us a total of 18 valence electrons. So now let's write our selenium as our central atom. And then first let's start off by drawing 2 single bonds to oxygen. And now I'm just going to fill in all of my lone pairs. So notice that selenium doesn't have a full octet yet, so I'm just going to make a double bond with my second oxygen, and I'm just going to count out how many electrons I have so far. So I have 16 electrons out of the 18, so for the last 2, I'm just going to put them on my selenium atom. So now let's calculate the formal charges of each of the atoms. So the equation for formal charge is equal to the number of valence electrons minus the number of non-bonding electrons minus the number of bonding electrons divided by 2. So first let's do the leftmost oxygen. So I'm just going to write oxygen that is single bonded. It had 6 valence electrons, and it also has 6 non-bonding electrons. And there's a single bond with the selenium. So we have 2 bonding electrons divided by 2. So this tells us that our single bonded oxygen contains a negative charge. And in the case of our double bonded oxygen, it also has 6 valence electrons. Now it has 4 non-bonding electrons. And there's a double bond, so we have 4 bonding electrons in total, divided by 2. So this oxygen is neutral. And then lastly, let's calculate the formal charge of our selenium. So there are 6 valence electrons. The selenium contains 2 non-bonding electrons. And there are 3 bonds in total for selenium. So we have 6 bonding electrons divided by 2. So 6 minus 2 minus 3 is positive 1. So that means our selenium will hold a positive charge. And we can also show resonance structures with our leftmost oxygen having the the double bond, and our rightmost oxygen can have the negative charge. Okay, so these are 2 Lewis structures for the selenium dioxide. And you can see the junior tutor said the same thing, but I'm just going to say that the single bonded oxygen should have a negative charge, and selenium will have a positive charge. But the Lewis structures are correct. So I'll just say that this solution is correct.